Now that we know how to find out something about the environment our programs are running in, we can use that to customize our display as a user looks at our program in different places. But we can now combine the things we learned about scaling objects to different sizes with what we just learned about getting information from the system. Our previous example worked well and kept the rectangle in the center of the screen, whatever the size was. However, it didn't change the size of the rectangle, and we often want the shapes on the screen to zoom in and out when we change the screen size. So let's look at that code again. If we look at the last two arguments to size, these are the width we want the rectangle to be and the height we want respectively. We're getting the rectangle in the right place because we're changing the starting location based on the height and width of the current display window. But we're not then going to draw a different size rectangle. Again, we can use variables here. Looking at our original code, we want a rectangle that is 1/10 of the window wide and 1/5 of the window high. We can now use mathematical expressions to write this into our code and replace the last two parameters. Now our code looks like this. Will it work? Well, let's see. It works for 200, 200. Let's try 100, 100. Well, it's produced a smaller rectangle, but it's not centered anymore. Let's look at that code again. Remember that we wanted to work out where the center was and then start drawing the rectangle a little bit off so that we drew the rectangle around the center? Well, we've hard-coded that little bit of distance into the rect statement by using width on 2 minus 10 and height on 2 minus 20 because those adjustments work for size 200, 200. Let's clean up that code to make it easier to read and use some more variables. And if we run this at various sizes, you can see that it's always drawing the shape scale to the current display, but put into the center. Let's walk through this a line at a time, assuming you set the size to something. We know that we want to find the center, and from before, that the center will be at the point that it's half the width, then half the height. We're going to reuse this half value, so rather than make our rect statement harder to read, we create new variables to store this calculation. Now remember that we looked at our original rectangle and worked out what its proportions were relative to the original display size? That is, we assumed that this was the way that we wanted all of our rectangles to look. Now we know how to specify every rectangle we draw so that we only need to know the width and the height to draw them correctly. Finally, we want to start drawing the rectangle far enough above and to the left of the center that once we've drawn the rectangle at full height and width, the center of the display will still be in the center of the rectangle. Now notice that this code is obtaining all of its values from the height and width set by the size command. We've removed all of the hard-coded elements, and this will now scale to whatever size display we want. If we wanted to change this rectangle from standing up to lying down, all we need to do is to change the two variables for W offset and the H offset in one place, and all rectangles from that point on will then change their orientation. This is very powerful, as it allows us to make big changes in programs by changing only a few bits of code. But it also stops us from getting numbers embedded in the code. We've extended our use of variables and used them in conjunction with system variables to make our images do what we want, however the display changes over time. Variables and expressions are the workhorses of computing. You can tell a program what you want to happen and then reuse the results later on in the same program to solve some very complex problems.